The tangents which are drawn to it suggest the flow of, that is the direction of the flow of a fluid or a liquid, as well as it gives the velocity at that specific point. Wherever the high velocity of an object is present, there its pressure is very low when you compare to that of an atmospheric pressure. The speed of the efflux is found here in case of the open tank, where one part of the tank is open and the fluid is rushing over it, that is outward flow of the fluid is studied here. Hello everyone, I am Brinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to the session 2 of chapter 10, that is Mechanical Properties of Fluids. In our last class, we had studied regarding certain introduction for the fluids, and we had studied regarding the Pascal's law as well as its applications given by the Pascal's law. Now in this class, let us study regarding the buoyancy as well as the pressure which is exerted, how the pressure deals with the liquids. So here we have got buoyancy. So what is this buoyancy? That is nothing but the force which is exerted by the water. So suppose if you consider an object over here in a beaker, water applies certain buoyant force, and here is the weight of the object. Here there are two conditions wherein the center of gravity of the object and the center of gravity of the water both should lie in a same vertical line. That is one condition for the object to float. The other condition is the weight of the object should be equal to the weight of the water. That's why the object starts floating. For example, you can take boat as an example, or a ship sailing on water, that is in ocean or a sea. So this can be an example which clearly tells you regarding the buoyant force. So now let us study regarding the blood pressure. Whenever you study regarding the fluids, it is always the first concept what comes to your mind is all about the pressure. So even in our body there is a fluid, and that fluid is nothing but a blood. So here we are studying regarding the blood pressure which is exerted by the blood. So flow of blood with certain pressure in the arteries and veins. You can see the flow of blood in arteries as well as in veins of a heart. So here the pressure of the blood within the vein should match the external atmospheric pressure. So external atmospheric pressure as well as the pressure within the heart should match. Okay, we have got a compression of the heart, that is known as systole, and the relaxation of the heart is called as diastole. We have systole as well as a diastole, compression as well as relaxation of the heart during its pump. So systole has to be 120 mmHg, that is a mercury level, 120 mmHg, as well as the diastole should be of 80 mmHg. This is the normal BP of, that is normal blood pressure. So here at the higher altitudes, the atmospheric pressure, what happens, it decreases when you compare to that of a lower altitudes. So these two has, while climbing the mountains during trekking or any other activities, and while diving into the swimming pool, those times you will have to check out through it, because you have to compensate the pressure of your heart as well as the external atmospheric pressure to have a healthy, good pump of the blood within your heart. So here blood pressure at the feet of the humans is said to be greater when you compare to that of a brain. That is all because of the altitudes. At greater altitudes the atmospheric pressure is low, and at lower altitudes the atmospheric pressure is very high. That is all about your blood pressure, how the pressure acts at the different altitudes, and in heart how does it act. Okay, next let us study regarding the streamline flow. So what is meant by streamline flow? As you all know, streamline means it's nothing but it's a curved path such that, so there is a curved path such that the tangent drawn to it, any sort of tangent drawn to it, that is one of the point is in contact with the surface. So these are the tangents which is drawn. So as you all know, so if you consider a circle, a tangent is drawn such a way that the point of the line touches a curve at this position. Similar way, you have got these number of tangents, and the number of tangents gives the direction of flow of the liquid, direction of flow of the liquid, through which way it flows and with certain velocity it flows at a point. That is all about your streamlined. So what is that streamline? It is straight or curved path which is drawn such that the tangents which are drawn to it suggest the flow of, that is the direction of the flow of a fluid or a liquid, as well as it gives the velocity at that specific point. So here, if the fluid flows such that its velocity at certain point is always same in magnitude and direction, then you can say it as streamline flow or a steady flow, or the one which flows orderly. Okay, so it says that if the fluid flows such that its velocity at a point, the velocity of any tangents, that is a flow of water at certain point, is having same magnitude and it is same in its direction, if both magnitude and direction both are same at that specific point, then the flow is known as orderly flow or a steady flow or else a streamlined flow. That is all about your streamline flow. Now let us move to Benoullis Principle. So here in this principle we have got that for a streamline flow, that is here we consider a streamline flow, the flow of liquid is in order. It has got a steady flow, okay, because its velocity at that point is said to be same in magnitude and direction. That is why a fluid is said to have a streamline flow. So here a streamline flow of an incompressible non-viscous fluid, that means it is an ideal fluid. The sum of potential energies for the fluid which undergoes streamline flow, its sum of potential energy, kinetic energy and pressure remains constant. That is nothing but your Benoullis principle. And how it is given? It is like you have got your potential energy, kinetic energy and pressure energy per unit volume. So let me consider pressure energy, and plus means it is a sum. We are talking about sum of all three energies, and potential energy is given by density, gravity and height. Okay, C is all about your potential energy, wherein in case of mass you are giving density instead of mgh you are giving rho gh, plus your kinetic energy is half instead of m, that is instead of the mass we are giving the density, it will be rho v square, that is half mv square is the formula for a kinetic energy. So sum of potential energy, kinetic energy as well as the pressure energy remains constant. Per unit volume is said to be constant. That is all about your Benoullis principle. This is all about the Benoullis principle and its statement and its equation which is given, that is P means pressure energy, rho gh is the potential energy and half rho v square is nothing but the kinetic energy. The sum of all these three energies are said to be constant. Now on moving to the illustration of Benoullis principle, just to know what is meant by Benoullis principle, there is a small illustrations for you. It is like when a high velocity, suppose if a house is present and there is a roof for the house, whenever the high velocity wind blows over the roof, suppose if this is a house and there is a presence of all the roofs. So here, suppose if there is a high flow of wind breeze in this manner, so of the house during a hurricane, a low pressure is created. So when there is a blow, that is a wind which is flowing and it is the greater pressure, what happens at this position? At the position very near to the roof, the pressure is said to be low, and there is a atmospheric pressure which is acting inside, from inside the house there is a atmospheric pressure which acts on the roof. So what happens? That atmospheric pressure means the one that is which is acting perpendicular, that is the force which is acting perpendicular on the surface. So when it is atmospheric pressure, the pressure acts perpendicular to this roof. So whenever the wind blows, since at the top layer the pressure is very low and here the pressure is high, what happens? The blowing wind blows off, that is it takes off the roof and it moves, that is it lifts the roof and the roof is blown off by the wind. That is a kind of illustration for you to understand clearly what is meant by Benoullis Principle. So it is a very short concept wherein you have to understand wherever the high velocity of an object is present, there its pressure is very low when you compare to that of an atmospheric pressure. So here now let us study regarding the speed of the efflux. Efflux means outward flow of the fluid. So it is also called as Torricelli's law. So here in this case, he found that the speed of the efflux, that is the outward flow of a fluid, whenever a tank, if you consider a tank, there is a pipe opening for it. So the water flows outside. So that outward flow is known as efflux. So here the speed of the efflux from an open tank is given by the formula which resembles the formula of freely falling body. Suppose you consider a tank. This is a tank which has an opening at O and the surface is said to be A. From this surface to this end it has got height h and the rest of the height is known as h dash from the ground. So consider a tank which is open at point O and from A to O it has got the height of h and rest of the from O to ground it has got the height h dash and the outward flow of the water is taken from this position, that is the tank where it is open. So suppose if you consider the Benoullis Principle equation that is given as we have total energy at height, that is height A, and which is equal to total energy at point O. The total energy at this place and this place we are checking out now. So according to Benoullis theorem, so we have got pressure P subscript A, for we are talking about A and here we just talk about the point O, plus rho G HA plus half rho VA square is equal to pressure at point O plus rho G height H naught plus we have got half rho V naught square. Now the pressure at A is same as that of pressure at O, so that cancels and we have got rho G HA and VA, H naught and V naught. At A, the velocity is said to be 0, so there is no flow. It is a stationary liquid, hydrostatic liquid, so there is no flow at the starting, at the beginning. Where exactly the flow occurs, that is at point O. So at point O, there is a flow. That means there is a velocity at O which can be told as V, and this is one equation. Now if we just consider height, the height at A is said to be h. We know that the height from O to A is h, and at O what is the height? It is nothing, it is 0, nil. So it is h naught is equal to 0. Apply the same conditions to the above equation. So you have got A here. So it becomes rho G and HA is substituted as h plus we have got VA. What is VA? It is 0. So the whole term gets cancelled. So here you can just write it as, instead of plus, you can write it as equal to. Then you have got rho G H naught. H naught is nothing but 0. The whole term cancels to 0. So we have got half rho V naught square. So what is V naught? It is V square. I can write it as V square. So your rho and rho gets cancelled because it's one and the same. So now here we are talking about the same density. So rho is one and the same. So you have got GH is equal to half and V square. Retain your V square as it is and this 2 goes with it. So you have got 2GH. So V is equal to root of 2GH, which is the equation for a freely falling body. Okay, so V is nothing but root of 2gh is the equation of freely falling body. That is what we told here. That is, the speed of the efflux is found here in case of the open tank, where one part of the tank is open and the fluid is rushing over it. That is, outward flow of the fluid is studied here, whose equation will be one and the same as that of the freely falling body. So what is this Venturi meter? It is one of the application of the Benoullis theorem or a Benoullis principle. In this case, it is a device which is used to measure the steady flow of fluids. That is, to measure the speed of the steady flowing fluids. This meter is used. So here it is constricted. This part is constricted and that part is known as throat. Okay, so at this point the pressure will be more. When the flow of liquid increases in the throat, what happens to its pressure? It decreases. Okay, when the speed of the fluid increases here, its pressure decreases. That is a concept which is undertaken in Venturi meter. So wherever the speed is more, the pressure decreases. Now let us study regarding the blood as well as the blood pressure and the heart attack caused. So this is also with regard to the Benoullis principle. That is the example you have taken, the Venturi meter, wherein you can connect certain things to this also. That is, the blood flows in arteries and veins, okay, and it get constricted due to accumulation of the plaque, that is cholesterol. See here, this is said to be the accumulation of the plaque, because of which the walls are constrained, it is constricted. So there is a formation of a throat kind of a structure, what I told you, constricted. It is not a widened pipe wherein the blood can flow easily. What happens to the blood? It gets clotted there itself. And you know, heart keeps on doing its work, that is, the blood keeps on pumping. Okay, whenever the speed of the fluid increases within the heart, what happens? That is, the speed of the blood in the region constricted is increased, because the heart keeps on doing its work, so the blood increases. Okay, at that time there is decrease in the pressure when the speed of the fluid increases within the heart. When the pressure decreases, I have already told you, it has to compensate with the atmospheric pressure. The outer pressure forces the vessels. Okay, so here when the outer, that is the external pressure acting at the same time, results in the collapse. Okay, it results in the collapse of the heart, causing an attack to it. So now what happens? The heart exerts certain pressure to open the artery, as well as at the same time there is an external pressure which is acting upon. So when these two pressures act, that is, when there is variation in the pressures, that is, inside it is very low and outside it is very high, these changes in internal pressures of the heart, what happens? It results into an attack. So the Benoullis principle, whatever we had studied, same thing can be applied to our functioning of the heart as well. So this is all about the fluid pressure, the pressure which occurs in the liquid state. In our today's class, we had studied regarding the streamline flow and buoyancy, as well as we had studied regarding the attacks, Venturi meter, Benoullis principle, and how it is applied to the blood pressure within a human heart. Okay, that's all for today. Let us all meet in our next session, that is session 3 of the same chapter. Until then, have a good day. Thank you.